Hey Pre-Calc students, welcome to Lesson 4.5 Notes, Day 2. We're going to continue with the idea of composition of inverse functions involving special right triangles. So these columns that you see on the table in front of you are the same thing that we wrote down when we took our notes for 4.5 Notes, Day 1. So it's just to review the reminders of what the restrictions are for inverse sine and inverse tangent, inverse cosine, reminders of how to set up your right triangles with radians. Remember that pi over 6 is 30 degrees and pi over 3 is 60. Pi over 4 is 45 degrees. Also, quick reminder that when it comes to quadrantal angles that land on the x or the y-axis, you want to use the coordinates, remembering that cosine is the x value of the coordinate and sine is the y value. I've been noticing that a lot of students are forgetting this relationship, so I'm going to kind of highlight it in blue. Don't forget that tangent, when it comes to quadrantal angles, and pretty much this is the property that's always true. The tangent of an angle is the same as the ratio of its sine over cosine. So tangent of theta equals sine of theta over cosine of theta, and it's reciprocal likewise, right? Cotangent then would be cosine over sine. So feel free to write this down if you feel like you need it, but again, we wrote this in a previous lesson, so you should have it written down already. Go ahead and pause the video if you are going to want to write this all down. If not, let's go ahead and keep going. So again, the title of this lesson is composition of functions. So we're going to be working from the inside out, pretty much from right to left. All right, let's go ahead and focus on this first problem. They want us to find the secant of the inverse sine of a half. So let's work from the inside out. So pretend this is the only thing that they're asking us. What is the inverse sine of a half? All right, well, whenever they ask me for inverse sine, I know that I'm trying to find an angle, and we're working with radians here. So the directions, let me zoom back in over there. So they want the exact value, radians only, no calculator. Provide a diagram. All right, so inverse sine lets me know that I'm finding an angle, but it can't just be any angle because sine inverse is restricted to quadrants 1 and 4. Now remember, everything in quadrant 1 is positive. Things in quadrant 4 can be negative. So since the ratio they gave us is positive, so sine inverse of positive 1/2, that is a big red flag that my special triangle is going to be in quadrant 1. Now my job is to figure out what the reference angle is here. So that opposite, right, opposite over hypotenuse, which is what sine is, opposite over hypotenuse is 1/2. So I want opposite over hypotenuse. Well, what angle is always across from the 1? That is 30 degrees, but in radians, we say pi over 6. Okay, so that means this would be pi over 3, and then this side length would be root 3. Okay. So what angle has a sine that equals positive 1/2? That angle is pi over 6. It's in quadrant 1. So that's the first part of the problem, okay? Now they're asking me to find the secant. Whoops. My computer loves jumping back and forth from the screen. I don't get it. Okay, so now we need to find the sine. So I'm going to go ahead and, secant. I'm going to plug the pi over 6 in for what was in yellow. Okay, so secant of pi over 6. Well, pi over 6 is in quadrant 1, right? So if you draw the angle, now technically I already have it drawn out. It happens just by coincidence that the angle that I want is already in my first diagram, but I'm going to redraw it just to prove a point, okay? So the angle pi over 6 is in quadrant 1. If I label all the side lengths, I can now answer the question. So the question is asking, what is the secant of pi over 6? So the secant of pi over 6, secant is the reciprocal of cosine. So instead of adjacent over hypotenuse, I want hypotenuse over adjacent. So from pi over 6, your reference angle, you want hypotenuse over adjacent. So that's 2 over root 3. Rationalize the denominator. And your final answer is going to be 2 root 3 over 3. Okay, remember you can rewind or pause the video at any time if you need to look at and listen to the explanation again. All right, as I look at number 2, I'm going to work from the inside out. So the first thing that I need to do is notice that they're asking me what angle, because I see inverse, right? What angle has a cosine of negative root 3 over 2? Cosine inverse is restricted to quadrants 1 and 2. But because the ratio is negative, that gives me a big heads up that the triangle that I'm going to be drawing is going to be in quadrant 2. So I'm going to go ahead and draw my special right triangle in quadrant 2. So the angle that I'm looking for is this obtuse angle that ends up in quadrant 2. That's the angle we're going to be looking for, okay? Now, which angle, 30, 60, or 45, has adjacent over hypotenuse that would give me root 3 over 2? So I'm going to want root 3 over 2. Notice it's negative because I went left. Whenever you go left or down, your side length is negative. All right, so think back to your 30, 60, 90 triangle. The angle who has root 3 adjacent to it is 30 degrees. So that's pi over 6. Now be careful because they're asking you what angle in quadrant 2 has adjacent over hypotenuse. So my reference angle is pi over 6, but the answer to this problem is not pi over 6. That's just your reference angle. The correct answer is 5 pi over 6. So you want an obtuse angle that ends up in quadrant 2 that is 1 pi over 6 away from 6 pi over 6. Okay, so 6 pi over 6 minus 1 pi over 6 makes this the angle of 5 pi over 6. Okay. So this angle is 5 pi over 6. The reference angle was pi over 6. So how far is the terminal side from the x-axis? 1 pi over 6. That means the angle is 5 pi over 6. Okay, enough beating of a dead horse, right? I said it like 300 times. So it is very important for you guys to make sure that your angle is correct because that's the first half of the problem. Now I'm going to go ahead and substitute that answer into the original problem. Now my job is to find cotangent of 5 pi over 6. Okay. 5 pi over 6, as I mentioned earlier, is in the second quadrant. Again, I'm redrawing the triangle just to kind of prove a point. You don't have to redraw it if you don't need it. So this is 5 pi over 6. It is 1 pi over 6 away from the x-axis. So this would be 6 pi over 6. Okay, so I'm redrawing it just to prove a point, but you don't have to redraw it if it's already on your first diagram. So using the reference angle of pi over 6, I need cotangent. Cotangent is the reciprocal of opposite over adjacent. So from my reference angle of pi over 6, I'm going to do adjacent over opposite. So adjacent would be negative root 3, opposite would be 1, and your final answer should be negative root 3. Watch out for the ones where they're cosine inverse that end up being obtuse angles, okay? That's where I see a lot of students make mistakes. So remember, the reference angle tells you how far the terminal side is from the x-axis. So you have to take that into consideration. Okay, so let's try a couple more, and then I'm going to have you pause the video and try one on your own. Work from the inside out. So cosine inverse of -1. Cosine inverse is restricted to quadrants 1 and 2. Now, which angle, 30, 60, 90, or 45, 45, 90, would have adjacent over hypotenuse that equals -1, essentially -1/1, right? Now, the 30, 60, 90 doesn't matter if you use the 30 or the 60 degrees, adjacent over hypotenuse will never equal 1. So that leaves the 45, 45, 90. Is it possible, whether you look at this pi over 4 or this pi over 4, for adjacent over hypotenuse to equal 1? No. So then we're going to use the coordinates of the quadrantal angles that land in that restriction between quadrants 1 and 2. These coordinates are 0, 1, these are 1, 0, and these are -1, 0. Cosine inverse is asking you what angle has a cosine or x value of -1. That angle, so from 0, this is pi over 2, this would be 1 pi. So that angle is pi. So cosine inverse of -1 is pi. So I'm going to go ahead and substitute that back in, tangent of pi. Now, I don't have to redraw the diagram. I'm going to stop doing that. In the previous ones, I was just doing it for drama, to exaggerate, okay? But here, tangent of pi, you already have pi drawn in your diagram, okay? Pi is that angle whose coordinates are -1, 0. Tangent of pi, the only way to find it is to use the property that tangent is sine over cosine. So sine of pi is the y value, that's 0. Cosine of pi is -1. And 0 divided by -1 is 0. Okay, for number 4, we're going to be working from the inside out. Remember, you can pause the video at any time. You can rewind and rewatch anything you want. Just make sure you are actively listening and asking yourself questions. Hey, how'd she get this? Where did this come from, right? So think it through. Okay, tangent inverse is restricted to quadrants 1 and 4. But because my ratio is negative, I'm thinking I'm going to need the triangle in quadrant 4. Okay? Because there are no negative side lengths. That came out really bad. There are no negative side lengths in quadrant 1. Okay? So I'm going to use the one in quadrant 4 instead. Okay, which angle has opposite over adjacent that would give me -√3/3? Would it be 30? Would it be 60? Or would it be 45? So 30 degrees is your pi over 6. 60 degrees is pi over 3. So this is like a process of elimination. Now I see the √3, so that tells me I'm going to use a 30, 60, 90. So try using pi over 6 as your reference angle. So pi over 6 is, for tangent, opposite over adjacent would be 1 over √3. Right? For the tangent of pi over 6, I'd get 1 over √3, rationalize it. And hey, that's what we want. We just want it to be negative, right? So that's why we chose quadrant 4. Okay, so our reference angle is going to be pi over 6. But if you look, so even though our reference angle is pi over 6, and we'd get side lengths -1, √3, and 2, that actual angle is negative pi over 6. So the actual angle is negative pi over 6, because you have to go down into quadrant 4 to get it. Now I'm going to substitute that answer back into the original problem. Sine of negative pi over 6 is opposite over hypotenuse, right? So you already have your negative pi over 6 drawn in your diagram. You don't have to draw another one. So from negative pi over 6, from that reference angle of pi over 6, you want opposite over hypotenuse, right? Because that's what sine is. Opposite over hypotenuse, that is -1 over 2. This is where I would like you to try a problem on your own. I want you to really think about what pieces you're understanding and which pieces you're not, okay? So I want you to try number 5 on your own. So pause the video, and when you're ready, you can check your answer by pushing play. Good luck. Please pause the video now. Okay, so I chose quadrant 1 to draw my right triangle in because everything in quadrant 1 is positive and I need the sine to be √2 over 2. I chose a reference angle of pi over 4, which is 45 degrees, because opposite over hypotenuse, right? Opposite over hypotenuse from here would end up rationalizing to √2 over 2. Right? Remember, sine is opposite over hypotenuse. So the correct answer here, since I want it to be in quadrant 1, is that I want to use the angle positive pi over 4. So now I'm going to substitute that back into the original problem. And now I'm going to focus on answering this part. What is the tangent of pi over 4? So I already have the diagram labeled, right? Positive pi over 4. I'm just going to make it a little bigger. All the side lengths are positive. Tangent of pi over 4 is opposite over adjacent. So here's my reference angle. Opposite over adjacent is 1 over 1. Okay, hopefully you listened and you paused the video, but as always, if you have any questions, feel free to reach out through a remind, email, or message. All right, have a great day.